Sir, sir, please continue. Mr. Suresh from IRIMEE has already been joined, and he will take a lecture on HVAC systems being used in Gen 18 and 24.
Very good afternoon, sir. Very good afternoon to all the officers and participants.
Suresh sir, please continue.
Yes, sir.
Your voice is
Yes, sir. Yeah, very good afternoon, sir. My name is Suresh from Amit Engineers, representing to give a brief details about the air conditioning unit, RMPU unit, which we are supplying to Train 18 project.
Excuse me, sir. Please increase your volume.
Yeah. Is it audible now? Can you hear me, sir, properly?
Sir. Yes, sir.
Okay. Thank you, sir. Yeah, we are going to look about the air conditioning HVAC unit, which we are going to supply to Train 18 project. So here we'll be basically covering from basic of air conditioning system and what is the type of system we are giving, what are all the components or new features added in this project compared to the first train set or from the LHB coaches. And we will focus more on the maintenance perspective and reliability brief. We'll be covering about what is HVAC and what is the system, how it is the basic fundamentals of the HVAC and the system. We'll be covering here, and performance of the HVAC, maintenance, reliability. At the end, we will cover on cab HVAC unit. Basically, why actually air conditioning system is required? Heating, ventilation, and air conditioning, that is called HVAC. So HVAC is required to provide the comfort to the passengers inside the coach to maintain the desired temperature and relative humidity. So basically, our body will metabolic system will work properly when the ambient temperature, I mean to say the compartment temperature where the humans are there, is properly maintained, so that the humans will get comfort by maintaining temperature and humidity. So to achieve this, what is the process basically? Cooling, dehumidification, heating, and air filtration. Cooling is to reduce the temperature from the initial temperature. That's where the refrigeration system works. Dehumidification, again, the refrigeration system will dehumidify by evaporation process. And heating is used for winter application. And above and all, air filtration is very important. The fresh air which comes from outside, as well as the recirculated air which is filtered through, there are two filters, one is the fresh air filter and mixed air filter. So by this, the air which is supplied through the coaches is filtered and supplied. Basically, this system is a vapor compression system, which is having this is the basic fundamental system in any refrigeration, vapor compression. And here the process is basically compression, condensation, and evaporation. This is how the complete cycle works. To give a brief idea, this is how the air conditioning system schematic. This is the compressor. A compressor, basically, it is what we are using is hermetically sealed scroll compressor. Basically, the compressor itself gives the meaning. It compresses the low pressure refrigerant to high pressure refrigerant. So that is the work of the compressor. Inside the compressor, there are mechanical parts, that is a scroll, fixed and orbital scroll, which is connected to the motor which rotates and sucks the refrigerant and again compress
Excuse me,
to
sir.
the. Yes, sir.
Sir, your slides are not
I is
propagating.
not seeing, sir.
You are not able to see.
So
Yeah,
slide
the
is not
first slide
seeing.
is coming,
Still.
but then
First slide still.
yeah, it's coming now.
You could able to see now. Now, okay, sir.
Yes, it's okay now.
Right, sir. Right, sir. Maybe some network issue. Yeah. So can I repeat once again?
Yes,
Yes, sir.
Yeah, this is the basic HVAC system, refrigeration system. Any vapor compression system will have the basic these components: compressor, condenser, expansion device, and evaporator coil. The compressor, basically, which compress the low pressure refrigerant to high pressure refrigerant. That is how the temperature rises and the pressure also rises. So again, to bring down the temperature and the pressure, it is passed through the condenser where axial fans are used in this system to reject the heat. So once the heat is rejected, it is in a vapor condition, will convert into semi-vapor condition. That is how the condenser process is happened, and then it passed through the expansion device where the sudden expansion throttling happen. Due to that, the temperature drop will be there as desired to maintain the room temperature. By that, there is a evaporator blower fan. In the evaporator, the room air and the fresh air is passed in on the one side of the evaporator, and it is thrown to the supplied through the duct. So that is how the blower will keep recirculating the air, and by microprocessor controller, the set temperature, till the set temperature, the compressor will be working and condenser fans will be working. Yeah, so far we discussed why air conditioning is required to maintain the comfortness to the human. I mean, the passengers who is traveling in the train, and what is the basic refrigeration system, how the cooling is produced. Now we are entering into the specification of the air conditioning system which we are supplying to this Train 18 project.
सुरेश सर आपकी आवाज बहुत कम आ रही है.
Yeah, is it clear, sir?
Your voice is coming very feebly.
Yeah, I'll just move my lap.
Please enhance your sound, sir.
Yeah, one second.
Sir, please play your slides.
Yeah, I just moved the laptop very near to the mic. So, is it audible now, sir? My voice is clearly audible to everyone?
Yes. Yes.
Yes, sir. So, basically, this is the specification of the
Audible, sir.
Sorry? Sorry, hello? Is it audible, sir?
Yes, audible.
It's okay, sir.
Continue, sir.
Yeah, somewhere some background noise is coming, but I am sitting in a closed room. Yeah, the cooling capacity is approximately 29 kilowatt at 50-degree ambient and 13% RH. Heating capacity is 10 kilowatt. It's exactly 9 kilowatt. And the dimension of the unit is 2.5 meters by length, 2.1 meters width, and height is 0.45 meters. And the fresh air volume is 645 cmh, and the supply air volume is 3600 cmh. The refrigerant used in the system is 407C, and the approximate weight of the unit is 800 kg. And here in this system, the new technology has been introduced, that is variable speed compressor. One compressor is variable speed, and the other one is fixed speed. And condensers and supply fans are fixed speed. I'll cover more in detail on the coming slides about what is the advantage of variable speed compressor and what is the difference between fixed speed and variable speed compressor. We have gone through the specification of the Sir, I would request if somebody want to talk something, that time you can switch on the mic. Otherwise, please switch off the mic. Hello. Sir, can you hear me properly?
हेलो गुड आफ्टरनून. हाँ ठीक आ रही है आवाज तो.
हाँ ठीक है सर, अभी ठीक है, अभी ठीक है. So now I'm going into the illustration of the components. What are all the components in the air conditioning system? There is one vertical compressor.
Switch off.
Yes, sir. Hello. Is it audible?
Voice is breaking.
Yeah, one second, sir.
Some one person are unmuted in position.
Hello. I would request the audience to mute the mic. If they want to ask question, that time please unmute and you can raise questions.
Please mute all the mics.
Yeah, I would request. Yeah. So here the illustration got two systems. One is the vertical compressor. I am showing the cursor here. This is the vertical compressor. This is again hermetically sealed scroll compressor. And there is one horizontal compressor, that is one A compressor, horizontal compressor one number. And these are all the mounting brackets. There are 8 mounting brackets where the unit is going to mount on the roof. And this is 2 axial condenser fans. And this is the 2 drain pipes which the evaporator, the condensed water, which is routed through as a stainless steel pipe inside the system, and it is protruded outside. From here it will be connected through the drain arrangements. And here there are the 2 heat exchangers, that is a condenser coils, and there are 2 accumulators in the suction line of the system, and fresh air dampers. See, this system is having fresh air dampers and 2 return air dampers. Normally LHV coaches and all, we have dampers, but whereas this is automated, the damper actuators are there which we can control as logic. There are 2 evaporator coils and blower fans, 2 fans with one.
Sir, audio completely stopped.
No audio.
No audio, sir.
नेगी साहब आवाज सुनाई दे रही कोई?
नहीं, कोई आवाज नहीं,
कोई आवाज नहीं आ रही।
आवाज नहीं आई सर।
कोई आवाज नहीं आ रही।
हाँ नहीं आ रही ना ये, अभी तो
बिल्कुल
खत्म
नहीं आ रहा सर।
किसी की सर कोई आवाज नहीं आ रही।
नहीं सर, नहीं आ रहा।
नो साउंड।
फिर से कनेक्ट हो रहा है, उसका कुछ इशू हो गया है।
अच्छा
हाँ,
कुछ इशू है,
उससे
ठीक।
फिर रिकनेक्ट हो रहे हैं।
Yeah, can you hear me, sir? Sorry for the interruption.
Yes, 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 yes.
Okay, now you're good.
Yeah, I have rejoined. Anyway, once again, I will go to the previous slide. I can explain once again, no issues. So this is the illustration, a parts illustration of the system. What are all the components inside the system? There is one vertical compressor and one horizontal compressor, that is a variable speed compressor. And there are 8 mounting brackets. And
PPT is not visible.
PPT is not visible now?
Slides not visible.
Oh,
Not visible.
Not visible.
one second, sir. Is it visible now, sir?
Sir.
Yeah, once again, I'll just repeat what are all the components in the system. One is the vertical compressor. This is vertical compressor is a scroll hermetically sealed compressor. Again, there is one horizontal compressor, which is a variable frequency drive compressor. And there are 8 mountings, 2 condenser fans, drain pipes at the back side, and this is condenser coils to reject the heat, and there are 2 accumulator at the suction line and 2 fresh air dampers. This is the fresh air damper, and 2 return air dampers. This is at the return air damper, return air provision, and 2 evaporator coils and 2 blower fans with 1 double shaft motor. And there is OHP, overheat protection, for the heater, and supply air duct. There is a supply air duct inside the unit. And this is an inverter variable triple VF drive, which will drive the compressor at variable frequencies based on the PID control. And there are two return air dampers, fresh air filters. There are two fresh air filters. Here there are to have a better clarity, this power connectors, this is the power connectors, power and control connectors are there, which is quickly we can fix and remove the hurting make. And earthing provided on the unit, which can connect on the body of the coach. And this is the provision where the fresh air which takes inside the unit coach through the blower. Earlier I have shown the 2D drawing. Here I am showing the 3D model, which will have a better clarity how the components looks like. This is the vertical compressor, horizontal compressors, condenser coils, evaporators, two accumulators, and service valves. Here the cartridge type pressure switch, and there is a side glass to view the quality of the refrigerant. So far we have seen a basic of air conditioning and how it going to function. What is the specification of the RMPU HVAC we are going to this project in 18, and components. What are all the components inside the HVAC unit? So now we are going in detail about the components level. Here I'll be covering the major newly added or new featured components. Like variable frequency compressor is newly introduced in Indian Railway and in that too in Train 18 project. So this is a small graph like how it is going to benefit the end customer by saving energy. Basically, the cooling capacity can be modulated, like based on the return air temperature, the PID control by the microprocessor will control the vary the cooling capacity by varying the frequency of the compressor.
Sir, change
So
the
this is
slide.
how like we could able.
Sir,
Sorry.
excuse me, sir, please change the slides.
Slides
We are
not-
just getting component of illustration or RMPU, not a visible graph visible in this slide.
Okay.
Sir, and also please maximize your screen, sir. It is not visible to us.
Yeah, I have done maximize my screen. It is showing in a smaller window, or the complete laptop is showing the full screen only.
No, sir. It is
Smaller
in,
window.
Smaller window, please play the slides, full screen. Please play.
One second. Yeah, it is okay, sir, now?
No,
no. Otherwise, press F5, sir.
Press F5 button, sir.
F5, 1 second. There's simply F5 or any control F5?
Simply F5.
Only F5.
In the bottom right side, sir, 80% is showing. No, that can be increased. That you can click it, sir. Full screen.
Yeah, yeah, 100.
this.
Yeah. Okay.
No,
Thank you.
Yeah. Is it better than previous one?
Yes,
sir,
sir.
actually, sir.
No, sir.
near
Beside that percentage, we have one computer window symbol, sir. You please click on that.
That also.
This one?
Yeah. Besides the percentage button, we have a computer symbol.
Yeah.
Desktop symbol. You press on
Correct. Yeah. When I press, it is going to 88%. I'm increasing to 100%.
No, near 100%, you have a window icon. So please put this window icon. Left side of 100%.
Oh, okay, this one. Yeah, yeah.
That you have to keep it.
Correct. Yeah, yeah. This is actually full screen. Is it okay now?
No, sir, near 100, 110%. First window of near 100, 110. Please click this.
This one, right?
Okay, okay, this.
Yeah, yeah. This one only. I
That one.
Now it is okay, sir.
No, sir, please click again. No.
First one. Yes, sir.
no, first.
Yes, sir. Yeah, this is.
It is not working out.
No, to have full screen, this one only. Slideshow.
Oh,
No, that is the correct one.
No, sir, on the top, view button is there, sir. View button, you find
Double
one
click on that one.
slideshow.
Double click. Please double click on it. I think it is correct now.
It is correct?
no, sir.
No, sir, the top there is view. One view is there beside that.
Correct. Yeah. Sorry.
Sir, at the bottom, right bottom, we have 1, 2, 3, 4 buttons.
Correct.
1, 2, 3, fourth button. You just click on fourth button, sir.
Double
Yes,
click
sir.
on
Double click.
Yeah, yeah. This is how I presented last time also. I don't see any problem.
That is only to show the slides. I mean, but not the view. Slide view is just fourth one. You should click the fourth one.
Yeah, yeah. Fourth one I already clicked. Still it is not visible properly.
No, sir.
Go to the slideshow, sir. After animation, slideshow is there. You can click on it.
In view,
Top.
File, home, insert, design, translations,
Correct.
animation, slideshow is there. Slideshow. You go to slideshow there.
Okay, okay, okay.
Then from current slide. Second one.
Yeah.
Yes.
This also again, yeah.
I think some problem is there, sir, in the system. You may continue.
Yeah, please. Yeah, but now I'm going to cover about the component level, like the variable frequency compressor, which is newly introduced in Train 18. So the purpose of this using this compressor to have some energy saving here to modulate the cooling capacity. So the compressor will run at lower voltage and lower frequency so that the energy consumption can be reduced. Yeah, particularly this horizontal compressor and vertical compressor, there is a small difference. This will be having a slightly bigger in size. Since it is horizontal, there is one additional oil pump is there in the mechanism to have a better oil circulation. So here the bold letter components, which is newly introduced in Train 18 project, where not in the previous projects or LHP, these components are not there. We have discussed about condenser coil, evaporator coil, expansion valve, filter dryer, side glass. These are all the common components which is in the system. Whereas a discharge line check valve, this is the discharge line check valve. Whenever the compressor gets off, there should not be any liquid fed black. This is a mechanically designed. So whenever the system switch off, it will not allow to reverse any refrigerant inside the discharge line. So this is basically the protection of the system.
Sir, please change the slide, sir. We are getting just 1B component slides showing. That's
Yeah, 1B component only I am explaining.
okay, sir.
Yeah, 1B component only. Here, if you see serial number 6, discharge line check
No,
valve.
sir. We are just seeing compressor only with the is a comparison variable capacity diagram.
Still,
Yeah, definitely.
isn't it?
So you might have some problems. Please check this.
Yeah, now you can see the 1B component, sir.
Yes, yes. Now I'm saying.
Visible, sir.
Okay, okay, okay.
Sometimes we
Yeah,
are not getting proper slide.
yeah. Earlier I was sharing the window. Now I share the entire screen so that now I hope it is clear.
Now, sir, it's clear and it is okay. Now continue, sir.
Yeah, yeah. Thank you, sir. Thank you. So here the serial number 1 to 5 is the regular component which is being used even the normal LHB coaches and even the first train sets. Here the from serial number 6, this is a discharge check valve which is to protect the compressor from liquid flooding back to the compressor when it is getting switched off. And serial number 8 is the service valve, GBC valve, and serial number 7 is the GBC valve, and 8 is air differential pressure switch. This is provided across the fresh air filter. In case the fresh air filter get clogged over a period of time, it will give a signal, false signal, so that the filters can be cleaned. So earlier there was no pressure switch, so that the filter get clogged, and we don't we'll be running the compressor for more time. So to avoid this, this differential pressure switch is introduced in the system. And there is a safety device, fire smoke detector, fresh air smoke detector. This is the smoke detector which is provided in the path of the fresh air. In case of any external smoke, it will detect and give a signal to take necessary action and safety point of view. There is a CO2 sensor. This is a CO2 sensor to maintain the ppm level inside the coach. Retainer damper actuator. This is how it looks. Retainer. This is an automatic retainer damper actuator connected to the microprocessor controller. And there is one fresh air damper actuator. A triple VF drive for horizontal scroll compressor, as I briefed you earlier, and there is one emergency inverter and microprocessor controller, one controller for 2 units. This is the schematic of the RMQ and the microprocessor controller. Like there is an electrical control panel which is provided inside the switchboard cabinet, and inside the switchboard cabinet itself, the microprocessor controller is fixed, which is having analog inputs, digital inputs, and digital outputs, and LED indicators. So now we go into the function of the air conditioning system. What are all the functions here? One is the cooling mode. In cooling mode, basically the constant heat transfer on evaporator from primary refrigerant to secondary air, which will take place excess sensible heat and latent heat inside the coach. And this system approximately, as I told, 28 kilowatt design condition. And function is basically to maintain the temperature, set temperature inside the coach, that is 25. And in cooling mode, once the set temperature arrived, there is a variable speed compressor based on the return air temperature. The frequency will vary by modulating the capacity. There are heaters available in the duct supply air in the HVAC unit itself. So in winter, in case the temperature goes below 17 degree, so that time all the systems will off, only heaters will work, and it will maintain the coach temperature to 21 degrees Celsius. There is a hygrostat also provided in the written air. For each unit is having one hygrostat. So in case of the relative humidity goes more than 60%, accordingly the system will work. This is the emergency ventilation mode. In case of failure of 415 volt, there is an emergency inverter inside the system. In this case, the return air damper will close and only fresh air will be supplied, so that passenger will not feel any suffocation inside the coach. And the airflow defined in a specification is 645 cmh per HVAC unit. That much it will deliver. There is a manual cooling mode in case of failure of the microprocessor controller. There is a manual cooling mode in the switchboard cabinet. So by activating the manual cooling mode, the system will able to run and give the desired cooling inside the coach. These are more about the control logic. Like the microprocessor controller is having all digital inputs, outputs, analog inputs and outputs. So there are temperature sensors, supply air temperature, return air temperature, and there is a fresh air temperature. Sensors are available. 3 sensors are available based on the input from the input signal from the temperature sensor. The microprocessor will control the motors and the compressors. Basically, the parameters like high pressure, low pressure, and if voltage is okay, then the system will function in a sequential manner. Other than the normal operation, there are safety controls, like there are a pressure transducer as well as the high pressure and low pressure switch, thermal overload protection, overheat protection switches in the system. So whenever there is a signal from or open, the TOP opens or OHP opens, the signal will be given to the microprocessor controller and immediately fault generated. And this train is having additional feature. The signals, the faults will be passed on to the TCMS display, so that needed action can be taken in case of any emergency or any fault. It can be addressed in the workshops. There's a brief temperature setting 1 to 7. Heating is 17 to 21 and cooling is 20 to 25. Normally, whenever the system switch on, it will take first and second compressor 30 and 5 seconds from the unit is switched on. There are, as I told, there are high pressure safety cutout switch, mechanical switch. In case the pressure exceeds 425 psig plus or minus 15, so it will switch off the compressor. The compressor will be switched off, and signals provided to the microprocessor as well as to the TCMS. Similarly, low pressure, and there is a control pressure switch. In case the system pressure goes below 275 psig, there will be a signal to the microprocessor and it will switch off one condenser fan, so that the desired pressure shall be maintained to have the better performance. There are thermal overload protector inside inbuilt in the motor. In case the temperature exceeds of the winding, the TOP will open and the TCMS will get a signal. Similarly, heater is having a three-stage protection. One is 65 degrees Celsius. If the supply air temperature reaches 65 degrees Celsius, immediately the heaters will be switched off. And there is one temperature, the supply air temperature sensor, the limit, it is programmed in such a way, if the temperature reaches 85 degree, then also immediately it will give an indication and switch off. In case of any failure of 65, the second level 85 and the third level is 130 degree, that is a fusible type. As well as the supply air temperature goes on the lower side below 5 degree, in that case also it will switch off the compressor. Since the supply air temperature goes below 5 degree, that is not good for human, it will give a cold shock. That's why this logic is there. In switchboard cabinet, there is a earth leakage protection device. If in case of any leakage in the current, immediately it will switch off the system, shut down the system. Smoke detector. In case of smoke, fresh air dampers will close for both the units. Message will be given to TCMS display, and fresh air dampers will open again after giving command. This is basically the fresh air smoke detector. So in case of smoke inside the coach, that is a separate system which TCMS will give a command and switch off the complete, shut down the complete air conditioning unit. That is a separate logic. This system is having a MPCB contactors, and the interesting point here, this unit is having a UV lamp in the return air path, where the return air and fresh air which pass on to this UV lamp. Over a period of time, the return air will be purified to avoid any bacteria, as well as the return air is placed in front of the filter, so that if any bacteria is forming in the filter also, it will give advantage to reduce the bacteria. There is a return air temperature sensor. Again, this is the air, according to the set point, it will switch off the compressors. There is a fresh air temperature sensor, supply air sensor, and hygrostat. This is how it looks. There is a hygrostat. In LHB coaches and all, there is one hygrostat which is placed in the middle of the coach, whereas in this case, which is having each unit having a separate hygrostat to control the humidity. As I briefed you, differential pressure switch is mounted across the filter. If the signal in this unit is high, it will give fault. Air filter is choke and need to be cleaned. This is a brief schematic how the controllers is connected to the TCMS. This is a brief inverter schematic. Yeah, so far we covered what are all the components and what is the function of the controller and how the air conditioning system will work based on the logic inbuilt in the controller. Now we are moving to maintenance of the HVAC unit. There are few components which periodic maintenance is required. That is return air filter, 2 weeks, 4 weeks, 24 weeks. Replace at 18 and 36 months. This is actually our DSO guidelines. And again, there is a fresh air filter. Again, the same condition, either 6 or 12 lakhs kilometers respectively. And evaporator coils, condenser coils. So these are all actually to be cleaned yearly once, and based on the practically the condition, we may need to even clean lesser than also, so that the system will work effectively to have the better energy. And the smoke detector need to be cleaned. There is a filter in the smoke detector that has to be cleaned in a periodic manner, so that we will not have any fault nuisance. To have the better reliability of the product, we should maintain the unit periodically, so that these are all the benefits we can get: reducing risk of failure, improving indoor quality, air quality and thermal comfort, and improving energy efficiency. So far, we have covered briefly and more in detail on the components and what is the function of the system and controller and maintenance, reliability of the HVAC unit. So what is the benefit we'll be getting? We have a reliable system, having a proper designed system as well as proper maintained. So far we have seen the saloon air conditioning system. This is a driver cabin air conditioning system. This is the overall view of the air conditioning system shown on the left hand side. And this is the brief description of the unit, specification of the unit. This is a 2 TR capacity and 2 kilowatt heating, 1.1 meter length and 1 meter width and 0.5 meters height. And all this complete unit is built with stainless steel SS304. The supplier volume approximately 1000 cmh. Again, here it is refrigerant 407C, and the maximum weight of the unit will be less than 150 kg. Here it is only hardly one passenger, one pilot. So that's why here it is a fixed compressor which will work continuously till the temperature, desired temperature reached inside the cabin. So due to network issue, if any of the points is not clear, I'm ready to take those slides once again. Please feel free to ask. I'll just go through from the first slide, so that if any, I'll put every few seconds those slides. If any queries, please feel free to ask. So we have covered about what is air conditioning system, why it is required, and what is the performance of the HVAC system, maintenance of HVAC, reliability, and cab HVAC unit brief. Basically, air conditioning system to give the human comfort by maintaining the temperature and humidity inside the coach. Not only the temperature and humidity, here air filtration also there. There are two filters, fresh air and mixed air. This is the fundamental of refrigeration system, how it will work. Brief specification of the saloon HVAC unit, cooling capacity, dimension, airflow, refrigerant weight, and major components, the variable speed, fixed speed compressor, and condenser fans and supply air fans. This is the components illustration. Yeah, I think during this slide only it was not clear. So this is the overall components illustration, like one vertical compressor, one horizontal compressor, and 8 mounting brackets, 2 condenser fans, drain pipes, condenser 2 coils, accumulators 2, fresh air dampers 2, return air filters 2, evaporator coils 2, blower fans 2, and one blower motor double shaft, and heater overheat protections, supply air duct, VFD variable frequency drive, and return air dampers and fresh air filters.
Excuse me, sir.
Yes, sir.
Why we are using two types of compressor, vertical and horizontal, as well as horizontal? Why?
Sir, actually, we want to have a modulated capacity, that is variable speed only can give a modulating capacity. At present, the rail suitable compressor vertical is not available. That is why we have gone to horizontal compressor. Otherwise, in other commercial applications, vertical normal compressor, variable frequency compressors are available. Whereas for a transport application, the horizontal compressor only available as on date. The vertical compressor variable speed is under development.
Okay, right.
So we hope very soon we'll be getting that. Maybe once we get that, definitely we also wish to have a similar one. Yeah. Here, this is the connectors where quick fixing controlled power cables are connected, whereas in normal LHB there are both the side connectors are there. Here in this case it is on one side, and the complete unit is mounted on the anti-vibration pad. 8 mountings are there. This is how the fresh air opening from the bottom, where the fresh air intakes and passes through the fresh air filter, and then to the mixed air, and then to the evaporator coil, and cold air is supplied inside the coach. These are all the 3D views of the refrigeration system components. 2 condenser coils, 2 evaporator coils, 2 compressors, vertical and horizontal, and accumulators, filter dryer, side glass, pressure switch, mechanical pressure switch, and hand shut-off valve for service purpose. To have a better cooling control, or modulating cooling capacity, the variable frequency compressors are used, and these are well proven in other applications. And here also we have done needed all the testing, and definitely it will give a reasonable energy saving over a period of time. The few of the highlighted components are newly added in the railway air conditioning system, that to Indian Railways. But yes, these are all used already in metros. These are all the proven system components, like discharge check valve, air pressure differential switch, air differential pressure switch, fresh air smoke detectors, CO2 sensors, return air dampers, horizontal compressor, emergency inverter, and microcontroller. This is how it is integrated, like between the microprocessor controller, and this is the switchboard cabinet, and this is RMPU. This is a schematic how it is integrated between all these three components. These are all the modes, cooling modes, and cooling mode basically to the set based on the set temperature. When the return air temperature minus set temperatures are greater than or equal to 1 to 2 degrees Celsius, condenser fans and one compressor will work till it reaches the set temperature. If the difference of the return air temperature and set temperature, that is return air temperature minus set temperatures, are less than 2, both compressor and condenser fans will run till the temperature reaches set temperature. Heating mode, there is a 9 kilowatt heater in one unit to maintain the temperature from 17 to 21 degree in winter condition. Here, if the difference of the set temperature and the return air temperature, that is the set temperature minus return air temperature, less than equal to 1, heater will on for 5 seconds and off for 55 seconds. If the difference set temperature minus return air temperature greater than 1 to 3, heater will on for 30 seconds and off for 30 seconds. If the difference of set temperature minus return air temperature greater than 3 degrees Celsius, heater will on for 55 seconds and off for 5 seconds. This is the dehumidification mode. If the relative humidity is more than 60%, so the compressor running time will increase and until the humidity reaches 60%. The emergency ventilation is also very important. Yes. In case of any power failure, to avoid any suffocation inside the coach, only the blower will run and supply the minimum air quantity as per the standard. In case of 415 volt failure, microprocessor controller failure, there is a provision to switch on the unit in the manual cooling mode so that the inside temperature can be maintained. This is about the control logic. What are all the sequences the controller will check and start working? The controller shall perform the following functions concerning control and regulation of the air conditioning system to maintain the desired comfort condition inside the coach. The controller will activate immediately after getting 110 volt DC. The controller will perform self-diagnostic check. If they are okay, it shall be indicated by the glowing LED for the controller okay. The controller will also monitor 415 volt AC power supply. If it is not okay, and then same will be indicated to TCMS as a fault. These are all the cooling and heating set point. These are all the safety components in the system. The system level protection, high pressure switch, low pressure switch, and control switch. The component safety, motor safety, this is the TOP inbuilt in the motor, and this is a heater protection. In case there are 3 level of heater protection: 65, 85, and 130. Smoke detector for fresh air. In case of any external smoke, it will indicate and immediately shut down the fresh air damper and give a signal to the TCMS for an immediate action. UV lamp is the new one which is introduced in this project to have a better air quality. There are fresh air temperature sensor, supply air temperature sensor. To control the humidity, there is one hygrostat in each unit. Air pressure differential switch. Brief about the interface between the microprocessor controller to the TCMS. The preliminary schematic of the drive. Periodic maintenance of filter, evaporator coil, and smoke detector. If any queries, please feel free to raise, sir.
इसमें सर
Which is refrigerant?
Hello, Suresh sir.
What refrigerant we are using?
This is R407C, sir.
हेलो सुरेश सर,
Yes, sir.
बोल रहे हैं दो कंप्रेसर में जो है हॉरिजॉन्टल है वही VVVF है
हाँ जी.
और वर्टिकल जो है वो फिक्स्ड स्पीड
हाँ, fixed speed compressor
both
and
are
variable speed.
VVVF.
No, sir. Only one compressor is triple V out. Since when initial stage only to pull down the temperature. Say for example, in hot summer the temperature will be high. In monsoon and winter the temperature outside temperature will be low. So that the initial pull down only both the compressor will be working. So once the temperature reaches, based on the PID control, the variable frequency compressor will be only running with variable modulating, so that one compressor will be off. So that way we will have a better reliability and energy conservation. Energy consumption will be reduced.
एक सर मैं पूछना चाहता था सर इसमें मतलब कि ऑक्सीजन लेवल के लिए कुछ होता है कंट्रोल के लिए ऑटोमेटिक ऑक्सीजन लेवल कंट्रोल है कि नहीं है?
No, we have a CO2 sensor. CO2 sensor, yes, it will read the ppm level inside the coach. If it is going more than 1000 ppm, we are discussing this logic with RDSO also. So the return air will close and allow more amount of air inside the coach, so that the ppm level will reduce. Basically, that is to have the reasonable amount of oxygen level inside.
Okay, sir.
Yeah.
Thank you for repeating.
Yeah, above and all, I would request, since this is a big platform and many of the railway staffs are there and officers are there, I would request we will not leave any refrigerant in the atmosphere and try to recover the refrigerant wherever possible if the system is okay, so that we can support the environment. There are many ways we can recover the refrigerant, even we can reuse. This is my kind request.
Definitely. Thank you.
Thank you, sir. Any queries? Still we have time. Any queries, please feel free to raise.
एक्सक्यूज मी सर,
Yes, sir.
ये आपका जो है मोटर कोच और जो ट्रेलर कोच में उसका कैपेसिटी कितना है?
Sir,
RMP
all the units are same capacity, so that is why we are having the variable frequency compressor, variable speed compressor. It will work based on the temperature inside the coach.
किसी और को मतलब भेज दिया अपनी जगह पे।
कैपेसिटी हो गया ना, जैसे RMP में एक साइड 7 टन है, दूसरी साइड टोटल 14 टन समथिंग है, तो इसमें कुछ ऐसा है क्या?
Basically, this
ठीक है, थोड़ा पानी मिलेगा? ये पीपीटी थोड़ा शेयर कर दीजिएगा प्लीज सर।
जी सर।
Thank you.
Sir, in driver care, we are using 2 times capacity of AC, which is related to Amit engineers or any other methods.
Sorry, sir. No, we are supplying for this project. This is customized for particularly Train 18.
Okay, sir. We are talking about 2-ton capacity air conditioner, which is used in DTC.
No, driver cabin AC, driver cabin.
Sir.
And guard cabin.
Yeah. Both, sir. Both. There will be 2 cab air conditioning units.
Okay, sir.
Yeah.
Thank you, sir. Thank you very much.
Thank you, sir. Sorry, sir.
एक कोच एक कार में जो है
जी
कूलिंग 16 टन का है।
नहीं, 7 + 7 14 TR, sir. More than 14 TR.
अच्छा, ओके। More than LHP coach.
Sorry, sir.
LHP कोच में 7 टन का जो है।
हाँ सर, इसमें तो ज्यादा है, उससे ज्यादा है।
इसमें ज्यादा है।
हाँ, इसमें उससे ज्यादा है।
ओके। Thank you, Suresh sir.
Thank you, sir. Thank you for your time. Any queries, please feel free to ask. Still we have time, more time.
एक सर क्वेश्चन और था
जी।
जो सर कोच के एंड पर रिटर्न एयर डक्ट होती है, तो जो मैं जो पहले क्वेश्चन कर रहा था, ऑक्सीजन लेवल एंड अदर थिंग्स हैं जो मतलब मिडिल में और एंड में जाके डिफरेंसेस हो जाते हैं। इवन जो लास्ट में बैठा होता है उसको मतलब क्या ना रिटर्न एयर से बहुत दिक्कत होती है। क्या ऐसी पॉसिबिलिटी नहीं हो सकती रिटर्न एयर कहीं मतलब मिडिल से भी ली जा सके?
सर वो कोच लेवल का डिजाइन है, लाइक मेट्रो कोचेस में ऐसा ही होता है, लाइक रिटर्न एयर है ना बीच में होता है, बट whereas this is the coach design, like again coach level design we have to discuss with the coach builders, ICF. But however However, sir, actually the system is designed in such a way there is a positive pressure maintains inside the coach.
लेकिन
So
ऐसा होता
that
है
much airflow is there inside. That much airflow supply is there inside. The positive pressure is maintained, and the return is also circulated properly. There won't be any issue.
लेकिन ऐसा प्रैक्टिकली होता नहीं है
जी नहीं वेरस डिफरेंट कंपार्टमेंट्स है सर वहाँ पे मे बी थोड़ा डिफरेंस हो सकता है बट वेरस इन ट्रेन 18 इट इज ओपन चेयर कार एट दिस मोमेंट सो देयर विल बी गुड इम्प्रूवमेंट anyway I noted down your points sir whenever I to have a discussion with coach builders we will discuss this
या बिल्कुल
yes sir